things that you can do at PyCon are great, but one of my particular favorites is the lightning talk. It's not started yet, but it's starting soon. Please come and sit closer to the front. The closer to the front you sit, the more the speakers can see you, the more they think you're engaged, the more they think you're engaged, the better their talks are. It's like a virtuous circle of lightning talk wonderfulness. So come near the front. If you're sitting way at the back, consider coming forward. Did you know that every single row forwards you move guarantees an extra 10% of enjoyment? And that is a mathematical fact. Welcome, everyone. Welcome to Lightning Talks. Come and sit near the front. Near the front is where the speakers can see you. It makes them happy. It makes their talks better. That makes you happy. There's no? Okay, great. So I think Harry can come and just set up with me. Both first speakers. I don't know where Eric. We're going to start shortly, so our first two speakers can come and get set up on stage. Great, welcome one and all to the Lightning Talks. In some people's opinion, the best session of all PyCon. But actually all the sessions are good, but this one's particularly good. Oh yeah. I'll give a little more time for a few more stragglers to come in. If you've just come in, come and sit near the front. If you came in ages ago and sat near the back, why not come forwards and sit near the front? You can stare at the speakers into the whites of their eyes and get more out of the session rather than hiding at the back and going on Slack or something. All right, everyone, I think we should make a start without too much further ado. My name is Harry. I am here to be your host for the Lightning Talks. I hope you've all been enjoying PyCon so far. I certainly have. How about you? Hooray! For anyone that's new to Lightning Talks, the Lightning Talk format is you have 5 minutes. That's a maximum of 5 minutes, although you can take less, to give a talk about pretty much any topic you like. We have one session of Lightning Talks now. You can also sign up for future sessions. There is a session tomorrow morning, which I believe there was a few slots left for. The sign-up sheets are by the registration. You just put your name up, and we make a selection and send you an email shortly afterwards to tell you if you're up for the next slot. There's a session tomorrow morning. There's a session tomorrow evening, sort of about this time tomorrow. And there's a final session on Sunday morning. They're great fun. You never know what to expect. Perhaps one talk is boring to you, but it's interesting to the person next to you. And then the next talk is boring to them, but interesting to you. They're just my favorite. My job here is to fill some dead air in between the speakers and tell bad jokes so that they sound better. Sorry about that. There's one little bit of Lightning Talks kind of administration, which is I'd like you all at this point to just practice the thing with me, which is clap with your fingers, which you do like this. Could you do that for me? Everyone? Like as loud as you can with your little fingers. Here we go. Can you hear that little murmur around the room? So that, when I basically give you a signal like this with one hand, you do that clapping like that, and that's going to be the signal to the speaker that their time is up, and they're supposed to finish their current sentence. I'll put up one hand, you do this murmuring clap. They get to finish their sentence. When I put two hands up, then you drown them out with applause, because A, you've enjoyed their talk, and B, their time is up, and we move on to the next person. Does that make sense? Shall we practice it? Blah, 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 blah. Without further ado, let me hand over to Eric. Please give him a big hand.
Hi, my name's Eric Smith. I designed F-strings and implemented them for CPython. So, thank you. So this is a talk about a feature of F-strings that I'm planning on adding for 3.8. But in all fairness, this is not my idea, it's Larry Hastings' idea. So if you dislike it, it is Larry's idea. If you're like me, you do lots of debugging with print statements. I do it all day long. And my print statements are often like this first line, x equals curly brace, x bang r, right curly brace, and you go on and on and on. And I don't know about you, but I find that all but impossible to type. I'm wrong more often than I'm right with the braces and whatnot. So this idea is to add a conversion operator, which is kind of like bang s, bang r, and bang a. And we're currently thinking of calling it bang d for debug. And the idea is that when you write f expression bang d in curly braces, it expands to the text of the expression, an equal sign, and the value of the expression. So now you can just write x bang d, y bang d, my long URL bang d in the expression bang d, and it will produce as its output the literal text of the expression. So if you've got spaces in there, it'll put the spaces in the output. My example here, with the 9 times x plus 15, it would literally print out 9 times x space plus space 15 equals 42. So hopefully this will save lots of typing for people like me, who is my audience. And this will be in 3.8. And that's it.
Thank you, Eric. Short and sweet. Up next is Shawn. Are you ready to go, Shawn?
I am.
Is your slide up on the screen? Look behind you.
It is up on the screen, yes.
All right, give him a big hand, everyone.
Okay, so I'm going to talk about a project I've been working on for a couple years called Data Test that deals with data wrangling, which can many times be awful. A little bit about me. My name's Shawn Brown, at 03SJBrown on Twitter. I started using Python in about 2006. And I work as the technology director for the National Committee for an Effective Congress, which we call the NCEC. And at the NCEC, we have done a lot of data analysis for a long time. But with a lot of data analysis comes with, a lot of data analysis means a lot of data processing. So we do a lot of data processing. And to make sure that the data that we get is accurate when we receive it and accurate after we do work to it, we've been working on this data test tool, which has 3 main features. So it provides validation methods to check that data satisfies a given requirement, difference classes that describe elements that fail to, when data elements fail to satisfy a requirement, they're expressed as these difference objects. And then it also provides acceptance context managers that accept differences that meet a specified criteria. One of the main functions, one thing I should say on that previous slide, it supports PyTest and unit test, but the slides here are PyTest specifically. And in the PyTest API, one of the main functions is the validate function, which is a rich comparison function. And in this example, the requirement is a set of A and B, and we're validating that the elements in data satisfy that requirement. And when validate is given a set requirement, it checks for set membership. When validate is given a function requirement, it checks that that function returns true when given the data element. It also works for mappings, lists, and other objects. This example, it's given two dictionaries. The difference objects I guess, when a validation fails, the validation error is raised and the validation error contains a number of these difference objects. The differences can be missing, extra, deviation, or invalid. Looking back at this first example, given this set here, there are 2 extra elements. So when you run the test, it sees, oh, C and D are not part of this requirement, so it fails with that validation error that contains these 2 differences. Likewise, with the function here, there are 2 elements that don't satisfy the is-even predicate. Here in the mapping comparison, this one does a numeric comparison, and it sees that that B contains 199 in the data, but it contains 200 in the requirement. And likewise, C contains 305 in the data, but 300 in the requirement. So it gives these deviations with -1 and +5. Ideally, you want to correct errors when possible, but sometimes you can't always correct errors. Sometimes two different reporting authorities disagree. Sometimes you don't have enough information, and sometimes there's a requirement that you maintain the data as it was reported. And in these cases, we have an acceptance system, and these act as context managers that accept certain differences based on these criteria, and if all of the acceptances, or if all of the differences have been accepted, the error is completely suppressed. So here in this example, back to that set membership test, C and D fail that test, and the differences are extra C, extra D. We can add this accepted extra, and then the test passes. If we've decided, with our own judgment that that's an acceptable thing to do. Same here, we have this two differences of -1 and +5. If we think that a deviation of 5 is okay, we can add this accepted tolerance of ± or -5. Acceptances can also be composed with operators, ampersand and pipe to do intersections and unions. You can install it with pip install. There's no hard dependencies. It supports many varieties of Python. It's freely available. And thank you for listening.
Thank you very much, Shawn. What was I going to say? Hey, you know what? When a speaker finishes and there's questions time, I don't think that's a nice time to leave the room, because it's like really explicitly saying, I'm finished being interested in this talk and I don't care about anyone's questions. So a small thing of politeness is maybe if you've stayed for a whole talk, stay for the last 5 minutes of questions as well, rather than walking out. I thought that in a room recently. It didn't feel so nice. Everybody at PyCon has been incredibly nice, so it's just a silly little oversight, I'm sure, on everyone's part. Yeah, I shouldn't probably open with a general critique of audience behavior. Haven't all our speakers so far been great? The next one will be great too. Please give a big hand to Elisaveta.
Hi, my name is Elisaveta, and today I want to tell you a short story which changed my mind. I'm a software developer of the PyCharm IDE at JetBrains. We're not a really big company, in fact, but we have several offices around the world, and the biggest one is located in St. Petersburg in Russia. It is situated in the office building named the Universe. During the latest years, we started to grow really fast, and we realized that Universe isn't enough for us. We started to look for the new office, for the new space for us, and finally we found it. We found the new office, and we called it Space. Our new office is a new building. It's really cool. We were very excited when you arrived there. It has 2 towers. It is located near the Neva River and near the Gulf of Finland. So we were really happy when we arrived there. It's a new building. It is cool and this nice Scandic style, and it was really nice. It doesn't have open spaces, just real rooms for 4 or 5 people. A really great place, right? And it was very good, but there were some minor things about it. It was still a bit under construction. For example, you want to use a printer, you come to a printer room, and then you realize that there is no paper there. Okay, no problem, the paper appears in a few hours. You go to a coffee point, and there are some coffee machines, but they don't produce hot water. Okay, no problem, you file the bug, and the fix appears with the next minor update. Now they produce hot water. Great. You go to a meeting room, and there are no whiteboards there. Okay, no problems again. You file a bug, it is fixed in a few hours, and you're happy. That's great. And in fact, you have nothing to complain, because every time the bug is fixed in a few hours, and there are no problems, and every day you see continuous improvements everywhere, every day. But the problem is every day you find new bugs as well. After several iterations, our new office was stabilized. Now it has a lot of happy users and a great view to a Baltic Sea. You can see it's sunny on this photo, but sometimes we have the weather exactly like in Cleveland. And one thing which changed my mind in this history, we all here create software, and everybody understands that it's impossible to create software without bugs. But this situation with the new building gave me an unforgettable experience, because it's very important for every software developer to find themselves in the situation where every users find themselves rather often. You definitely should do it, and I believe it will change your mind. At least it changed mine. Thank you.
All right, thank you, Elisaveta. I have a little joke about a lady's, I heard this from a Polish programmer friend, and she tells me this joke. Says, this is my granny's favorite joke. It's a lady's walking down the road, and she sees a horseshoe. So she picks it up and looks at it and turns it over, and on the other side, there's a horse. Please give Meredith a big hand.
Thanks. So my name is Meredith. I run a startup called Anvil. We make tools for building full-stack web apps with nothing but Python, and we are sponsoring PyCon again this year. It's great to be back. Like any good sponsor, we give out T-shirts to anybody who builds an app with Anvil and shows it to us at our stand. There are two problems with this. One, as you've probably guessed from my accent, we're not from round here, so all the T-shirts have to come with me in a very heavy suitcase. Problem number two, Python developers, it turns out, come in all sorts of shapes and sizes. Here are two people who program in Python, and the shirt that looks good on the one on the left is not going to look very dignified on the one on the right. So the question is, how many shirts in our limited space should we be bringing of each size? And, I mean, we've done this before. We could just be naive. We could say, well, however many we gave out last year, bring twice as many. Last year we gave out 2 women's extra smalls. We should maybe bring 4 this year. That makes sense. Last year we gave out 27 men's large shirts. Bringing 54 feels a little bit like overkill, you know? It's the law of large numbers. That 54th men's large shirt is so much less likely to get used than that 4th women's extra small. It's the law of large numbers. Larger sample sizes average out more reliably. We can model this with a binomial distribution. We roll 3,500 dice, one for each of you, and we just count up how many of them rolled men's large. And thankfully, it turns out that SciPy has a function for calculating exactly this, and so I'm going to use it to build an interactive tool for exploring this distribution. I'm going to write a function that gets this distribution for a given number of attendees and a given probability of needing a particular size of shirt. So we return the PMF for that number of attendees and that probability for every value up to the number of attendees. Okay, so we have our distribution. We can now make an interactive tool to explore it. We're going to go to our user interface, have a text box where we can enter how many of this shirt we used last time, and then underneath it we're going to stick a plot so we can explore the distribution. And when you hit enter in this text box, we're going to call that get distribution function we made earlier. The number of attendees is 3,200, that's PyCon. The probability is actually, we can get this from the number we gave out last time, because that was also over a population of 3,200. And once we've got the distribution, then we can just plot that data as a bar chart whose y values are that distribution. So, okay, let's run this. And let's explore the women's extra smalls, right? We gave away 2 last time, and if that's any guide, the distribution's actually quite wide. We're most likely, of course, to need 2 again this year, but we could easily need twice that number, or even more. Whereas if we go with the men's larges, again, gave away 27 last time, but the distribution's a lot tighter here. We're still, again, most likely to need 27, but we're vanishingly unlikely to need twice that number. So now we've constructed a statistical model that can actually answer our question, because we want to know how many shirts to bring, because we don't want to run out. And what we want to do is find a number of shirts of each size where there's a 95% probability that we will need that number or fewer. And again, SciPy to the rescue, it has a function for calculating this. We're going to return this alongside the distribution. It's the PPF, so we're going to find the 95% points for this number of attendees and this probability. Back on our user interface, that is the number of shirts we should be giving out. So we want to display this. We're going to stick a headline on our page. Oops. No. We're going to stick a headline on our page. And then, as well as plotting the distribution, we're going to put some text on that headline saying, with the instruction, bring so many shirts. And now if we run this, we can see that if we want, so with the women's extra smalls, we brought 2 last year, we actually need to bring 5 this year to be 95% sure of not running out. Whereas with the men's larges, we only need to bring 36. That's only 9 spares out of 27. All the source code for the app I have just written is available at tinyurl/overthinking-t-shirts. And if you want to know more, please do come past our booth at the exhibition hall. And you know what? If every single one of you turns up and you all build an app with Anvil and you completely clean us out of shirts, well, at least that'll show the statisticians. Thank you very much.
Thank you, Meredith. Pirate programmer walks into a bar and he's got a parrot on his shoulder, and the parrot's going, "Pieces of 7, pieces of 7." And the barmaid goes, "I think there's something wrong with your parrot." And the programmer goes, "Yeah, he's got a parity error." And the barmaid goes, "Yeah, I thought he was a bit off." Please give Matty a big hand.
Hi, I'm Maddie P on all kinds of social media. I'm a full-time NumPy developer in my day job. I'm 1 year into a 2-year contract, and I'd love to talk to you all about that, but not now. People want to talk about it. Either we can do the hallway track or come to SciPy in Austin in July, and we'll be talking about that. I really would like to talk to you about PyPy. How many people have heard about PyPy? And what if I told you that PyPy is not PyPI? Now, how many people have heard about it? It's an alternative Python implementation written in Python. It has a JIT, which makes it really fast, and a different GC, and it's fast. How fast? Blazingly, astonishingly, amazingly, incredibly, impressively fast. And the disclaimers will be at the end. Now, how many of you have actually used PyPy? Could you stand up? Not very many, right? But look around. Everybody who saw somebody who stood up, they can ask them how their experience was with it. You can actually try PyPy yourself. Would you like to see a demonstration of it? Want to see it again? It was fast, right? So I can't actually show you a demonstration. I'm not going to show you a demonstration right now. If you want to try it out, you can download it. You open up a zip file, and it's basically like a virtual env or a different Python distribution. You do PyPy -m ensure pip, which provides you with now you've got a nice pip environment. PyPy -m pip install the world, and we promise that works. Disclaimers at the end. So the good news is this should all just work. Okay, the disclaimers are that PyPy may cause anxiety, feelings of inadequacy, frustration, a desire to rip your CPU out of your computer, and if you feel any of these symptoms, don't blame us. Okay, but really pip install will sometimes need a compiler because we're just now building wheels and starting to, now that Many Linux 2010 is a thing, yay for the PyPA. We're going to start uploading some wheels to PyPI. Pure Python should be very, very fast, but some C extension modules like NumPy may not be as fast as you'd like them to be. And if you want more information, talk to me or visit us at our website. Thank you.
Hooray! I have another story about a Russian watchmaker, but I feel like these lightning talks are so slick, there's absolutely no need for anyone to hear that. Are you ready to take us away, Jelly? Please give him a big hand.
Hello, everyone. I'm Elisaveta. I'm a software engineer over at Quora in California, which is a great place to write Python code if you're interested. I also contribute to open source software like Typeshed and Black, but I'm not here today to talk about that. I'm here today to talk about biology. Because I actually started out in college as a biologist, then turned into a software engineer. But I still like to think about biology sometimes, because I spent all of college staring at fossil teeth like this one. So what I do now, outside of my day job, is maintaining this big database of animal names. Mostly mammals, some other animals. I try to cover every single species that exists, every name that has been published, of which there are now more than 80,000 in my database. And I'm gathering data like who named each species, where was it published, where did each species come from originally. And I'm making a lot of progress in getting closer to completion for every single mammal, know where it came from. There's 40,000 names given to living mammals, and I got to 99% progress on their locality so far. So why am I doing this? Really, the main reason is because this is what I like. I enjoy working on this. I like reading about animals. But I think there's more. It helps to document the biodiversity of the world. There's many species that are in danger of going away that we don't understand well. And gathering all this data helps us figure out what is going on in the world and what kind of, how diverse mammals are now, how diverse they were in the past. And if I gather all this data, that also just makes it easier for actual scientists to focus on their research, actually working with animals, rather than having to look up literature and look up details of nomenclature. And last, it's just interesting as a piece of historical research. I can answer questions like, which historical mammal researcher was the worst at making up names because all of their names are no longer considered valid? It turns out that's this guy, Leopold Joseph Witzinger. 19th century Austrian zoologist. He described hundreds of new species. Almost none of them are considered valid nowadays. What I want to do in the future is extend this with a website, because currently it's just a database that I maintain, but I want to make sure that other people are also able to use this data and maybe contribute to it. I want to add more automation just to catch more issues like bad pieces of nomenclature, bad interactions between names that are easy to add because I have this nice Python app that maintains my database and can find issues, can report about things. Maybe also just cover more in the future, like more kinds of animals, more kinds of data. Yeah, if you want to know more about this is how you can reach me. I'll be at PyCon. You can find me by email or on GitHub. Yeah, thank you.
Thank you, Jelle. So this Russian watchmaker is getting to the end of his career, and he decides that he's going to invite some of his friends around to look at his shop and decide what the most beautiful object he's ever made in his career is. And his friends look around the shop, and they look at all the things, and eventually one of them goes, oh, I think I found it. And he goes, what? And come over here, he says, I think the most beautiful thing in the shop is this. And he goes, what are you pointing at? The bracelet on this watch. And he goes, ah, yes, this is Gregor, the bracelet. It is very beautiful. Tell me why you think you like it. He goes, oh, well, I like the way you've alternated silver and gold links. I like, that they're finely carved. And in the end, if you haven't got a bracelet, you haven't got a watch. So that's why I think it's the most beautiful object. And the Russian watchmaker goes, no, it is not the most beautiful object. And then the second one has another idea, but we'll hear about that idea after Jacob's talk. Please give him a big hand.
Oh. I feel like I should just go quickly so we can hear the end of that one. But I'll start off with my favorite joke, actually. Have you heard about the restaurant on the moon? It has great food, but no atmosphere. So anyway, I'm Jacob. This is my first PyCon. I come from the land down under, not quite Perth, the other side in Melbourne. And to give you an idea of how far away that was, my flight here left at 9:30 a.m. on Tuesday and arrived in LA at 6:40 a.m. on Tuesday after 14 hours of flight. So yes. So I'm a PhD student over in Melbourne. I'm doing my astrophysics PhD, and so I thought I'd come and talk about how astronomers use Python. I will give a quick disclaimer. This should actually be how some astronomers use Python. A lot of my contemporaries and colleagues are actually doing a bunch of cool stuff involving machine learning, looking at gravitational wave signals and things such as that. So if you're interested, please feel free to come and talk to me. But I'm a simulator. I simulate galaxy evolutions, and so in astronomy, we have data. And unfortunately, we have a crap ton of data. So I did a quick LS of one of my directories, one of my output models, and as you can see, the total is 118 gigabytes worth of data. And so I'm running for this for 5 different models, and I'm trying to collapse all of this into a single image that I can put into one of my papers. And so this is how astronomers use Python. We use NumPy, we use matplotlib, we use SciPy. That's really it. I thought up the idea of this talk, and then I realized the punchline isn't that intriguing. But anyway, on the more observational side, we have this. This is the square kilometre array out in the desert of Australia. Australia is great for radio telescopes because you need a whole lot of no radio interference, and Australia has a whole lot of nothing. And so when the SK is operational, we expect that 10 petabytes worth of data will be coming in every single day. And so we need to use data analysis tools such as Python to crunch through all of that data and produce beautiful things that we can put in our papers. So for example, this movie here that I've made used data that would have come from this SKA telescope, 10 petabytes worth of data. It used things such as NumPy, SciPy, matplotlib to produce this image. So if you've ever wondered how do astronomers use Python, the answer is pretty boring. NumPy, SciPy, AstroPy, and matplotlib. Thank you very much.
So the second friend goes, I know why it's not Greg or the bracelet, because I think the most beautiful object on the shop is over here. So our watchmaker goes, oh, okay, well, what have you found? He goes, I think it's the dial on this watch. I think it's beautiful. And he goes, yes, it is Vanya, the dial. I think it's beautiful as well. Tell me why you think you like it. And he goes, well, I just like the way you've got little diamonds encrusted at each of the cardinal points. I like the way you've used Roman numerals. That's really classic. And in the end, if you don't have the dial, you can't tell the time. So that's why it's the most beautiful object. And the Russian watchmaker goes, no, it is not the most beautiful object. Because he has his own idea, which we'll find out about after Jesse's talk. Please give Jesse a big hand.
Hi. This is for the first time come to PyCon US, so yeah, thank you. I'm Jesse. I'm a software engineer at Crashy, which is an edtech company based in Tokyo. I mostly work in both data science and engineering. So in the last year, I've been developing and refactoring research-oriented code and faced with some struggles. So based on my experience, I'm going to try to identify the differences between research-oriented code and production code. So why I'm going to talk about this topic is that recently Python engineers have more opportunities to work with data scientists or researchers than before. So understanding each other can help make AI ML projects work more smoothly. So there are 3 differences between research-oriented code and production code. First, different scopes of data scientists and engineers. And second, different characteristics for each and different objectives for each. So now see definition of research-oriented code. Research-oriented code in AI ML project is a code written mainly by data scientists or researchers and for figuring out the most efficient suitable machine learning model. So this is the image of how research-oriented code can be developed. So research-oriented code is developed through an iterative process and integrated into production code. So this code is based on analysis scripts and or prototype. So data scientists or researchers have responsibilities to write research-oriented code. Now, on the other hand, engineers have responsibilities to write production code, the whole part of the code in production level. So let's look at an example. Machine learning APIs are composed of 3 elements. So in this case, production code includes preparation code, preprocessing code, machine learning model. On the other hand, the research-oriented code includes preprocessing code and machine learning model. So this is an example of data preprocessing code written by researchers or data scientists. This code uses an empty list, for loop, and if and also. And it seems to be long, but this code can make it possible for everyone to visually trace the code from the top to the bottom and easily, quickly write it. So this is an example of machine learning model written by researchers or data scientists. So there are one simple calculation function on the top, and this code uses data frame and DOTAPAN. So this code can allow researchers or data scientists to easily handle input data with data frame and trace output data. So what are Python engineers supposed to do for research-oriented code? So refactoring in Pythonic way. So this code seems to be shorter than previous code, and on the bottom there are simple calculation function, and there's list comprehension, set comprehension. Actually, this code can build a model in a much faster and simpler way. So let's wrap up. Different scopes of data scientists and engineers. Data scientists have responsibilities to write preprocessing code, machine learning code. On the other hand, engineers have responsibilities to the whole part of the code in production level. So second, different characteristics of coding style. The research-oriented code seems to be easy handle and visually traceable. On the other hand, production code can have high calculation speed, high readability, and it can be testable and modular. In the last, different objective coding style. So researchers or data scientists focus on finding the most efficient, suitable machine learning model. On the other hand, engineers make the code work on the server correctly and quickly. So this is why research-oriented code does not seem to be necessary to be concerned about calculation speed and readability, because their priority is in finding out the most efficient, suitable machine learning model. So that's all. Thank you so much.
Thank you, Jesse. So the two friends go, well, come on, all right, if it's not Gregor the bracelet and it's not Vanya the dial, what is it? And so the Russian watchmaker goes, come with me. And he takes them to the back of the shop. And in a dusty little part, he finds this old watch. And he points at it and he goes, look here. It's a sort of nondescript watch. And they go, what? And he goes, look, the second hand. The second hand on this watch is the first second hand I ever made in the first ever watch. I call him Olaf. And you see, Olaf is counting along the time. And that is the true essence of a watch, and that's why I think it's the most beautiful object in the shop. And his two friends go, no. And so they get into a huge argument about it. I think it's, Olaf, I think it's Gregor, I think it's Vanya. And so they're going to need an impartial third-party referee to help them decide it. And I'll tell you who the third-party referee is after Rebecca's talk. Please give Rebecca a huge hand.
Hello, everyone. My name is Rebecca. I work at Google on a tool called PyType, which analyzes Python code for type errors. Now, PyType is publicly available, and it's hugely popular inside Google. But outside Google, people always have one particular question about it. There exists a popular Python type checker called MyPy. So the question is, how is PyType different from MyPy? I'm going to explain the two main differences and then show a code example for each. So let's start by talking about MyPy. MyPy has a philosophy of gradual typing, which means that you opt your code piecemeal into type checking by adding type annotations. MyPy is also a very strict type checker. It does not allow operations that change the types of objects. On the other hand, PyType analyzes all of your code, whether it has type annotations or not, and it uses type inference to figure out the types in unannotated parts. It's also more lenient. It will allow any operations that would be allowed in untyped code as long as you're not contradicting explicit type annotations. To make this more concrete, let's look at a couple examples. First, here we have a function f that returns a string and a function g that takes that string and adds it to an integer which is wrong, doesn't work. Let's try to catch this bug with type checkers. First, with MyPy, we are adding type annotations to our code to opt it into type checking. We annotate G, so that's body is type checked, and then we annotate F, so that MyPy knows the type returned by F in the body of G. And then MyPy will say, hey, you're adding a string and an integer. This is a bad idea. On the other hand, when we use PyType, PyType will analyze this code even if it has no type annotations. What it will do is it will go into G, see that G calls F, and then analyze F to infer that it returns a string, and finally it says, hey, you're adding a string and an integer, bad idea. Now let's look at an example of strictness. Here we have a function getList that declares it returns a list of strings, but in the body, it creates a list of a string and then adds an integer to the list and returns that. An integer is not a string, so there's clearly a bug here, but on which line of code? Now, if we use MyPy to analyze this, it will say that the error is on the second to last line, because remember, MyPy is very strict. It says you've created a list of strings. If you add an integer, you violate the type of that list, which is not allowed. But if we use PyType, PyType doesn't report an error until the very last line. This is because PyType says at runtime, you can put anything you want into a list. So you've created a list of strings. You've added an integer, and that's OK. That just mutates the type to be a list of strings and integers. However, this now no longer matches your declared return type. So then that very last line is an error. So to recap, I've talked about two type checkers with very different philosophies. MyPy does very strict type checking of code that explicitly opts into that checking by adding type annotations. And PyType does more lenient checking of all of your code by using type inference. Thank you.
Thank you. So they need an impartial referee. So they get Tina Turner. And Tina Turner comes to the shop, and she says, what's going on here? And she says, well, they were arguing about which is the nicest watch, or part of a watch. And the first one says, oh, I think it's Gregor the bracelet. And the second one says, I think it's Vanny the dial. And then the actual watchmaker says, oh, I think it's Olaf. And Tina Turner goes, Olaf? What's Olaf got to do with it? What's Olaf but a second hand in motion? Thank you. I'm here all weekend. Please give Catherine a huge hand.
All right. Hello, PyCon. This is DocAssemble. It's not my baby, but you've never heard of it, and you should. That's why I'm here. So I am not a full-stack developer. Even when WASM comes out, I still won't be, because I can't do a style sheet to save my life. Maybe I should learn Anvil. But in the meantime, what I want to be able to do is just throw up a form here to collect some information from a user, and I want to be able to define it really easily. So that, for example, I could say we're making an application to collect data for potential rideshare partners to Ohio, where you're going to come in July, right? So what if you could define your questionnaire pretty simply like this? And yeah, what if it was that easy? Let's take the Zeppelin. Why not? The Zeppelin can fit a lot of people. That's pretty cool. All right, so what this has done is it has gathered a bunch of data, and using a platform called DocAssemble, which is a high-level platform that is used for two purposes. It collects data and then it assembles it into a document, not into documentation, but into its design purpose is to put that data into maybe a PDF, maybe a Microsoft Word document, something, a legal document, something with boilerplate paperwork. It will get shoved into a big metal filing cabinet. And that is why it is called DocAssemble. However, that's not the only thing it does. Before you put this information in there, you need to collect it from the user. And that's the part that I think is the most interesting, because going through an interview, as DocAssemble calls it, with a user, collecting data, that is not a rare or specialty problem. That's a really common problem. So DocAssemble has this name implying that it's a very specialized tool, but the truth is, it also does something that is not so specialized. I wouldn't have called it DocAssemble if I'd written it. I would have called it Spanish Inquisition, but oh well. So if you looked at this interview, you will notice that it was YAML, which was pretty cool. It was this very specialized DSL, which just kind of describes the questions you want to ask. I don't know if you noticed that there's no control flow in here. So if I back up and I change my mind, and I say, you know, we're having a problem with the hydrogen in the Zeppelin, and we don't have any vehicles at all. So can't provide a vehicle, so it just cuts straight to, thank you, we'll see if we can find your rideshare partner. Where's the code that said, okay, now we don't have to ask for the type of vehicle? It is actually not in here because DocAssemble works backward from the end. It looked at my final slide, saw that I didn't, or my final question, saw that I didn't need any vehicle details, and so it skipped those over. It's an interesting way to structure an application. You can specify control flow if you really want to, but generally you don't want to and you don't need to. Let me see if I can. So the dual screen has me confused. So it's in Python. It's extensible in Python. You can include chunks of Python in it. That's all really cool. The documentation is absolutely amazing, including every time they show you a piece of syntax, they link to a live demonstration online. So we could actually I think the touchscreen isn't hooked up with the dual screens. But in any case, amazing documentation, tons of batteries included to easily do all sorts of tasks, mostly centered around if you're gathering information to produce legal documents, the community this came out of, but a lot of really interesting stuff. The batteries are welded in. If you don't want to generate PDFs, tough, the libraries are there. That is something that I would love somebody to wade in there and make it removable. The workflow is kind of designed around people who aren't professional coders. As described, you can figure out how to hook it into your IDE, but that's not the way the documentation points you, so that's kind of an issue. And then the big problem with it is just that it's kind of unknown among you folks. So even though DocAssemble has its own community, its own Slack channel, its own people answering questions, there hasn't been a lot of contact with the greater Python and PyCon community. I hope that'll change. They're actually running their own conference. These talks are online in my GitHub. Give it a try. I hope you like it.
Thank you, everyone. Our next speaker is Anthony. Please give him a huge hand.
Hello, my name is Anthony Lupinetti, and I founded and run a nonprofit called Open Source Kids, and our mission is to teach the children of New Mexico computer science. And by children, I mean specifically kindergartners through 5th grade students, 5-year-old to 11-year-old students. And today I'm going to tell you about something that I use in my teaching. When I teach 4th and 5th graders Python, I use something called Snappy Code that I created. So Snappy Code is a Blockly implementation of Python 3.7, and it's designed specifically to help young students learn Python. And so far, we've used it in about 3 schools with 1,200 students since 2015. And what can you do with Snappy Code? What can kids do? Well, they can create programs with blocks. Most of the students that I'm talking about can't type large quantities of code correctly without some difficulty, so we use block-based code. We can focus on concepts, not syntax, and they can see immediate results right there in their screen. They can learn from examples, they can debug problems, they can make art. We augment their STEM learning by working on geometry, things like angles and number of sides and shapes, that sort of thing. And we can control hardware, which we do in 5th grade, things like microbits and the Circuit Playground Express that everybody got in their swag bags. So what's included in Snappy Code? Here's a short list of what's included. Lots of different things from Python, all of the basics, and a number of libraries to boot. So I thought I would show you a little bit about what we do. This is a screenshot of one program, but let's go to this. And after we learn the basics of how to use snappy code, we learn that there are toolboxes that we can choose. We can save blocks. We can run examples. We then would move on to something a little bit more complicated where we're building bigger programs and we're learning something about how Python works. In this example, they're learning about print. They're learning a little bit about numbers and what the operators in Python look like. And the users would click run, and in the terminal on the side of the screen, you would see the printout just as if you were to type this and run it. And then on the side, they see a printout of the Python code. We can save that Python code and run it however we like in the future. If we move on from basic concepts like how to use the tools and what a print is, we move on to something like turtle graphics, where we can explore concepts in a graphical way. So this program is designed to make a shape. So we would write this program together. This would be fourth graders. We would run it, and it would open up a screen showing our turtle graphics window. We see a triangle. And we might proceed from something like this to working on loops. We might grab a for loop, talk about patterns, and while we were talking about patterns, we would talk about looping. We would learn how to use our loop structure in snappy code and Python. We would identify patterns, put them in our loops, and run our code. And we would see that we can make the same shape much more simply. And if we wanted to, we could then explore by changing numbers, looking at the relationship between sides and angles. So that's a very powerful way for them to reinforce the geometry that they're already learning. After that, we may move on to more complicated ideas. In fifth grade, we incorporate hardware. I have a Circuit Playground Express here. It's flashing some Morse code, SOS, so if anyone wants to SOS me, that would be great. But what we're going to do with this is see how we might use this to run something like a rainbow. And this is taken off of the Adafruit tutorial examples. And what we would do with this one is not run it, but rather save it. We would find our Circuit Playground right here. We would save it as code.py, and we would push the code, and in a second it would start producing our rainbow effect. And then we could move on to change this in many different ways. You can see here we're using more sophisticated concepts like functions. So if you're interested in learning more about this, you can go to snappycode.org. There will be a version of this posted online, or you can go to GitHub and download an installable version for Mac and in the near future Linux and Raspberry Pi, or follow us on @snappycode. And I'm also hosting an open space tomorrow, 10:30 to noon, if you'd like to learn more about it or discuss lesson plans. So thank you very much for your attention, and I hope to see you tomorrow.
Thank you very much. What do you call an apposite pachyderm? This is a joke that relies strongly on the audience knowing the meanings of both the words apposite and the word pachyderm. But the answer is irrelevant. Yeah, I made that one up, yeah. So please give our last speaker a huge hand. His name is Chris.
Thank you all for staying for the last lightning talk of our first day here. I'm going to talk to you about a less kind, less gentle sort of data frame. So I've used pandas for over 6 years now, and I can say it has vastly increased my productivity. And for that, I'm tremendously grateful to the pandas developers for their contributions. Critical to pandas utility is its efficient performance, its powerful routines, and its concise syntax. But not so critical to it are its what I would call kinder and gentler API. That is, there's very often multiple convenient ways to do the same thing. And while this might be quite appropriate for data extrapolation, data exploration, and notebooks, isn't really appropriate for every use case. In my practice, I'm building libraries and applications for financial systems. And I find that pandas is often a little too kind and too gentle. In my practice, I do not want kindness or forgiveness. I don't want gentleness or accommodation. What I want are discrete and strict interfaces, pure functions, and fast failures. For that reason, we create a static frame. Static frame offers an alternative to pandas dependent only on NumPy. It's been in development at research affiliates since 2017. Our first open source was in 2018, and we're already using it in production. So while pandas is kind in allowing you to set any column you want to be an index, even if that index is not unique, and even if that resulting index is going to be kind of awkward to deal with later on, pandas will happily let you set it as an index. Static frame is less kind. Static frame insists that all indices are unique, and if you try to create an index with something that is not unique, you get a handy exception. While pandas is very kind in allowing you to do multiple things with the getItem syntax. The getItem syntax can be used to select a column. That's its overwhelming use case, I would say. It can also be used as a little shortcut to, given a Boolean list or array, to actually select rows. It can be used both for selecting columns and for rows. Static frame is less kind. Static frame insists that the getItem syntax is only used for selecting columns, and if you want to select rows, you need to use an LOC selection. While pandas is kind in allowing you to wrap an array. So for example, here I create an array and I give that to a data frame. I can mutate that array external to my data frame, and those mutations show up in my data frame. Pandas is very nicely wrapping the array and providing an alternative interface and yet an alternative way to mutate that frame. Static frame is less kind. Static frame only wraps immutable arrays, and as such, if you give it an array, static frame is going to take it and make it immutable, and you will no longer be able to mutate the lingering reference hanging over from after your creation. Finally, while pandas is very kind in giving you lots of flexible ways to mutate your data frames. For example, functions like sort values allow you to use an in-place argument, so you can mutate your frame in place. Similarly, you can directly assign to a data frame using an assignment statement. Pandas offers lots of flexible ways to mutate your data frames in place. Static frame is far less kind. Static frame is based on immutable NumPy arrays, and as such, you cannot mutate the internal data. If you want to call a function like sort values, it will give you a new frame. If you want to actually mutate a value, well, you cannot do an LOC assignment into a frame. Instead, you use an assignment-like interface that through a function call gives you a new frame, never mutating your original frame. Now, we all know kindness is a virtue, but sometimes not in our APIs. Less kind, less gentle APIs reduce opportunities for error, aid in refactoring and testing, and promote better code. So please check out Static Frame. It's an initiative that we've been working on for a few years. We'd be interested to hear your comments, ideas, and suggestions. And you can come talk to us at the Research Affiliates Job Fair on Sunday. Thank you very much.
All right. Thank you very much to each and every single one of our Lightning Talk speakers. Thanks very much to each and every one of you for coming into this room, for giving them a round of applause, for giving them your attention. Thank you for being here at this conference. Thank you if you're a speaker or a volunteer or an attendee. I hope you've really enjoyed your first day. I certainly have. Please sign up to give more Lightning Talks. There's some tomorrow morning, tomorrow evening, and Sunday morning. Enjoy the whole of the rest of the conference. Have a lovely evening, and I'll see you all tomorrow or tonight or sometime. Hooray!